Hey guys, today we are looking at the Pythagorean theorem. Our learning target is to use the theorem to determine the lengths of sides of a right triangle. All right, so here's the Pythagorean theorem right here. A squared plus b squared equals c squared. And what this basically means is that A and B are legs of a right triangle. The legs are the ones that come together to form that right angle. So the legs are touching that right angle right here. And remember, a right angle is 90 degrees. So it has that 90-degree angle. And then your C is the hypotenuse. Hypotenuse just means the side that's your longest side that is directly across from your right angle. All right, we're going to try some together here to make sure you understand how to use it. So remember, our Pythagorean theorem is a squared plus b squared equals c squared. A and B, remember, are the legs, the shorter legs, and then C is our hypotenuse, the longest length that's across from that right angle. So for this first example, for number 3, our legs are these two right here. So we would have 21 squared plus 20 squared equals C squared. Then we would take that and actually figure out what each of these are. So 21 squared is 441. 20 squared is 400, and then c squared is still unknown. Add those two together, we get 841 equals c squared. Well, we want to figure out just c. In order to do that, we take the square root of both sides. Well, the square root of c squared is just c. And the square root of 841, I plug that into my calculator, and I find out it is 29. Try number 4 without me, and then we'll see if you got it right. So hit pause and try out number 4, and then hit play when you're ready to see if you got it correct. All right, for number 4, hopefully you plugged in your a squared, because here's one of our legs and here's the other leg. They form together that right angle. So a squared plus b squared equals c squared, and you should get this. Check your work, see if you got it. Add those two together, we get 144 equals c squared. And then we take the square root of both sides and end up with c equals 12. So the length of this side is 12. All right, what I want you to do next is try out number 5 for this one. Be careful because one of our legs is our unknown. So for this one, you're going to set it up as a squared plus b squared equals, and then we know our c squared. So set it up like that, and then you're going to use train tracks to help you solve for your a. So hit pause, try it out, and when you're ready to see me work it through, hit play and see if you got it right. All right, so I have it written out with my a squared plus 5.6 squared equals 10.6 squared because we do know our hypotenuse is 10.6 this time, and so our unknown is one of the legs. And so I'm going to calculate using my calculator what each of these are when I square them. 112.36. And then this is where I'm going to use train tracks because I want to get that a all by itself. So I'm going to subtract my 31 and 36 hundredths. And I end up with a squared. These two end up to be 0, and I get 81. Then, I don't care what a squared is, I want to know what a is. So I'm going to take the square root of both sides, and I end up with a equals 9. And so what that means is that the length of this side is 9 inches. All right, for these 3, hit pause and see if you can do these without my help. I'll work them one by one. Just be really careful to make sure that you're looking at what you know and what you don't know. So for example, this first one, you know one of the legs, but you don't know the other. So you're going to set it up as 9 squared plus b squared equals 15 squared. And then you're going to solve for your b. So hit pause, see if you got them right. And here's the answer for number 6. Use train tracks and subtracted 81 from both sides, and I ended up with b squared is 144, took the square root of both sides, and ended up to find that b equals 12 millimeters. And here's number 7. For this one, we had one of the legs, so we had our A, and then we had our C, which was known, and what we didn't know was our B. So I set it up like this. I solved for each of the squares there and ended up finding that B squared equals 576. Found the square root of both sides, and I ended up with B equals 24. All right, for this last one, I knew my B and my C, so I plugged those two in and squared them, and we're trying to figure out A squared, and then subtracted 16 from both sides, ended up with A squared is 136.1 repeating, and I took the square root of both sides, and we would end up with A equals 11.6 repeating, which is the same thing as 11 and 2/3. All right, for this one, your job is to try to figure out what is the error. What was the mistake that this person did? So hit pause, see if you can jot down what you found is the mistake. And then when you're ready to see the answer, hit play. All right, hopefully you figured out that they put the 25 as one of the legs, but if you look here, the 25 feet, that is a hypotenuse, it's the longest length. So that 25 squared should actually be in place of the C squared. So I set it up here as correctly, so we have the 7 squared plus B squared equals 25 squared, and then we would subtract 49 from both sides, and we get B squared equals 576. And we take the square root of both sides, and we end up with B equals 24. All right, for number 11, we're trying to figure out the missing length of the figure. So for this one, our missing length is that guy right there. In order to figure him out using the Pythagorean theorem, we need to know what the length of this is right here. Well, when you're looking at a square here, and we have these little marks, these little guys, this just means that each of these lines is the same length. And so if we know that this one is 12 centimeters, then we also know that this one is 12 centimeters. So that helps us set this up. So I look at this and I say, well, this one right here that's missing, that's one of my legs. And my leg is my A or my B. It doesn't really matter which one. And so I'm going to put in here 12 squared, because that's one of our legs, plus our missing leg equals 20 squared. Don't forget to square each of them. That's the most common mistake, is forgetting to square each of those. So we have 144 equals x plus x squared equals 20 squared, which is 400. Then I'm going to use train tracks to solve for my x. I'm going to subtract 144 on both sides, and we get x squared, and 400 minus 144 is 256. Then I'm going to take the square root of both sides, and we get x equals 16. So the length of that missing leg is 16. So hit pause, try number 12 without me. All right, for number 12, this one you had to solve two triangles in order to figure out that x, because we need this length right there in order for us to use the Pythagorean theorem to solve for that one. And since we don't have two missing sides in that one, we have to actually solve the triangle over here first. So to solve this triangle, we're going to set it up so that this is our unknown. And I just gave him a label of B, just so it's clear. So we have, on this side, we have 5 squared plus our unknown B squared equals 13 squared. And that's going to help us figure out the length of this line right there. So we have 5 squared is 25, 5 times 5 is 25, plus B squared equals, and then 13 squared is 169. I'm going to use train tracks to solve for my B. So I subtract 25 on both sides. We get B squared equals 144, and the square root of both sides, B equals 12. So now if we know that B equals 12, we're going to go back over here, and we have this length now is 12. So now we have two legs, because those two form those two legs, and x is our missing hypotenuse. So we'd set that up with 12 squared plus 35 squared equals x squared to solve for that x. And 12 squared is 144. 35 squared is 1,225 equals x squared. Add those two up, like terms, because they're both numbers, and we get 1369 equals x squared. Take the square root of both sides, and we end up with x equals 37. All right, this one's a little bit of a challenge problem here. The legs of a right triangle have the lengths of 28 and 21 meters. So we know legs are the two that form together to make that right angle. So we know one of them is 28 and one of them is 21. And then we have the hypotenuse has the length of 5x. What's the value of x? So to set this up, we're going to use Pythagorean theorem, and I'm going to put in here 28 squared plus 21 squared equals, and I'm going to put a parentheses around my 5x because I need to square both the 5 and the x. If we wrote it like this would just mean that we're squaring just the x, and that's not what we want. We want this entire length to be squared. So in order to square that entire length, we have to have these parentheses so that that square squares both the 5 and squares the x. So I'm going to solve what I can for what I know, and we know it is 784 plus 441 equals, and then I'm going to square what I can. So 5 squared is 25, and then my x squared is just going to be x squared. Notice when I multiplied that squared in, the parentheses could go away because I used the parentheses. So now, add up what we can. We have 1,225 equals 25x squared. And this becomes a train tracks problem. So I need to figure out what x is. And so I'm going to divide both sides by 25. And this then becomes x squared, because that 25 cancels to 1. And we end up with 49. Oops, that's a 4. 49 equals x squared. Take the square root of both sides. X is 7. So what is the value of x? X is 7, and so then the length of this side over here, if we needed to figure that out, is 5 times 7, so the length of that side would be 35.